Hello students and good morning to you all. So today I am doing the topic matrix. In the last online class also we were doing the same topic, that is matrix. So today is your continuation class. So we will do more problems today. Okay. This class is for class 12 science, right? So now we will do from exercise 1, page number 136. And the section is, each question carries 5 marks. Now, let's do the problem now. We will do question number 10, number 1. That is from exercise 1. This is page number. I already told you that this is page number 136 from XII book, right? So 10 number 1 is, if capital A is equal to second order matrix is given, in the first row 3 and 1 and in the second row -1 and 2 are given, and here I is the identity matrix of order 2, that is 1 0 0 1, and the norm matrix O is equal to, you know norm matrix, if all the elements or if all the entries of the matrix O are 0, then this is known as norm matrix. Okay, so and O is equal to 0 0 0 0. Since this is the norm matrix, you have to show that this relation a square minus 5a plus 7i is equal to O, that is your norm matrix. Hence you have to find out A inverse. Okay, so now let us prove a square minus 5a plus 7i is equal to norm matrix. Okay, so first of all we will do the first part, that is you have to prove LHS is equal to a square minus 5a plus 7i. What is a square here? A dot a minus 5a plus this is 7i is equal to, what is a dot a now? A dot a is, this is your, this is a is 3 1 minus 1 2, and also a is 3 1 minus 1 2. Okay, a is repeated twice here. Then again minus 5, and what is a out here? Again it is 3 1 minus 1 2, right? Plus 7. Plus 7, what is I? It is 1 0 0 1. So this is your given matrix, okay, or given expression. That is your left hand side. Okay, now you multiply these two matrices. You can multiply them first row by first row. You know how to multiply these two matrices, isn't it? First row by first row, 3 3s are 9, 1 into -1 -1. This is the first element of the first row. Now next, this first row is multiplied by the second column. 3 1s are 3 plus 1 2s are 2. Okay, now this is the first row. Now next, second row into first column, -1 into 3 -2, right? Again -1 into 1 -1, this is plus 4. So this is the product of the two matrices, right? Now again, now in this case -5 is the scalar multiplication of this matrix. Okay, so you have to multiply all these entries by -5. These 3 1 -1 and 2 are also known as the entries of the matrix, or this is also known as elements of the given matrix. Okay, then plus, now multiply all the elements by 5, -5 -15, then -5, then plus 5, then it is -10, right? Plus again 7 is the scalar multiplication of the identity matrix. So you can multiply all the elements of the identity matrix by 7. So it is 7 1s are 7, 0 0, this is 7, right? So now let us simplify it further. So is equal to, now what is 9 minus 1? It is 8. What is 3 plus 2? It is 5. Minus 3 minus 2 minus 5, and -1 plus 4 is 3. This is your 8 5 minus 5 3 plus. So now you can add those two matrices. They are of same order, isn't it? So -15 plus 7 is -8, -5 plus 0 is -5, and then 5 plus 0 is 5, minus 10 plus 7 is, this is your minus 3. Is that clear now? Now let us add these two matrices again. You can add those two matrices because they have got the same order, you know that, isn't it? So which is equal to 8 minus 8, 0, 5 minus 5, 0 minus 5 plus 5, 0, and 3 minus 3 is 0. That is your null matrix O, proved. So is that clear to all of you? So this first part is done. Now hence find A inverse. Now you have to use the proved relation. You have to use the relation that is just proved now. Okay? Hence you have to find out the matrix A inverse from the relation that we just proved. Okay? Now this relation, that is A square minus 5A plus 7I is equal to O, is used to find A inverse. So in the last online class, I told you about the properties. We have proved the first part, that is A square minus 5A plus 7I is equal to O. Now we have to find out, hence find A inverse. That is, this relation is also used. That is, we just proved the relation A square minus 5A plus 7I is equal to O. We will use this relation to find out the matrix A inverse. Right? So in the last online class, I told you about the properties of matrices. That is, properties of matrices. Okay? The properties of matrices, that is, with A inverse, A dot A inverse is equal to A inverse dot A is equal to what? I. So it is just like your algebraic simplification. If you have X inverse dot X is equal to X to the power minus 1 plus 1, that is X to the power 0, which is equal to 1. But in this case you cannot write 1 because 1 is not the matrix. So you have to write I. That is your identity matrix. Okay. Next, A dot I is equal to I dot A is equal to what? This is the given matrix A. It is just like your 2 1s are 2 or 1 2s are is equal to 2. Right? So A dot I is equal to I dot A is equal to A. And you can write A plus O is equal to O plus A is equal to given matrix A. It is just like your 2 plus 0 is equal to 0 plus 2 is equal to 2. Similarly, A plus O is equal to O plus A is equal to A, where O is the null matrix. Okay. Next one is A dot O is equal to O dot A is equal to the null matrix. It is just like 2 into 0 is equal to 0 into 2 is equal to 0. But in this case, A is multiplied by the null matrix is equal to null matrix dot matrix A is equal to what? It is the 0 matrix, that is null matrix. Okay. So we will use these properties for this relation to find out the matrix A inverse. Is that clear now? So let us write down the first part. What is the first part that we just proved? So it is A square minus 5A plus 7I is equal to the null matrix O, right? Or what is A square? A dot A minus 5A plus 7I is equal to O. So now what will you do in the next step? So now in this case you have to find out from this relation A inverse, right? So you multiply both the sides by A inverse. If you multiply left hand side by A inverse, you should multiply right hand side by A inverse also, right? So let us multiply both LHS and RHS by the matrix A inverse. Within bracket A dot A minus 5A plus 7I is equal to A inverse dot O, right? Or this is A inverse A dot A minus 5A inverse A plus 7A inverse I is equal to. Now what is A inverse dot null matrix? You know that it is the null matrix. It is just like I told you that 2 into 0 is equal to 0 into 2 is equal to 0. So likewise, what is A inverse dot O? It is O. Is that clear? Next, what is A inverse dot A? That is your I from this relation. A inverse dot A is equal to what? Identity matrix. That is I dot A minus 5. What is A inverse dot A? A inverse dot A is equal to what? I. Then plus 7 again. What is A inverse dot I? It is just like your A dot I is equal to A. Now here it is 7A inverse is equal to the norm matrix, that is O. Right? So next, or what is I dot A? I dot A is equal to the given matrix A minus 5I is kept as it is plus 7A inverse is equal to the norm matrix O. Right? Next, since you have to get the matrix A inverse, so 7A inverse, you keep it on the left hand side. So 7A inverse is equal to, now take this I minus 5I to the right hand side, so it becomes 5I minus A. Okay? Now on the right hand side, you can put the value of the matrix, identity matrix and the matrix A, or this is your 7A inverse is equal to, this is 5, what is I here? It is 1 0 0 1, and then minus, what is A here? This is 3 1 minus 1 2. Is it clear now? Or this is your 7A inverse is equal to, this 5 is the scalar multiplication of this matrix. All these elements can be multiplied by the scalar quantity 5 here. That is constant. That is multiplied by 5 here. 5 ones are 5, 0, 5 zeros are 0, 5 ones are 5 plus. So this is your minus 1. So minus 1 is the scalar multiplication of the matrix. So all the entries of this matrix can be multiplied by minus 1. That is minus 3, minus 1, minus 1 minus plus 1. This is your minus 2. Is that clear? So next. So next is 7A inverse. 7A inverse is equal to, now you can add those two matrices. They are of same order, isn't it? So you can add them. Corresponding elements can be added now. First element plus first element, that is 5 minus 3 is 2. Right? Next, 0 minus 1 is minus 1. Then 0 plus 1 is 1. Then 5 minus 2 is 3. So this is the matrix. Okay? So what is A inverse now? So it is just like cross multiplication, right? So when this 7 goes to the right hand side, you should write it in the denominator. That is 1 upon 7. So it is 2 minus 1, 1, 3. Right? Or what is A inverse now? So A inverse is equal to, multiply by 1 by 7 here. You have to multiply all the elements by the scalar quantity 1 by 7. That is 2 by 7 minus 1 by 7. This is 1 by 7 and that is 3 by 7. So this is the matrix A inverse. Okay? So now this is the answer for the second part, that is A inverse. तर हामीलाई के लाग्छ A inverse right छ कि wrong छ हामीलाई doubt भयो. Suppose you can check it also. Okay? You can check whether A inverse is correct or wrong. So you have to find out A dot A inverse. It should be I, isn't it? So if you find out A dot A inverse, you should get I. That is, I means identity matrix 1 0 0 1. So if you don't get A inverse is equal to I, there is somewhere wrong out there. You have to check it once again, right? तिमीले के निकाल्छ रे A dot A inverse is equal to I भनेर प्रुभ गर्नु. यदि I भनेर आएन भने चाहिँ कतै स्टेपमा रङ छ भनेर बुझिहाल्नु. बुझ्यो? तर A dot A inverse is equal to I आएछ भने that is the correct one. You will get full marks, right? So let us check it. So let us check whether this A inverse is correct or wrong. So let us check it. A dot A inverse. So you should get A dot A inverse as I, isn't it? You should get A dot A inverse is equal to I. Let us check it. So what is A out here? What is A? This is 3 1 minus 1 2 dot, what is A inverse? It is 2 by 7. This is 2 by 7. Next, minus 1 by 7. Next, 1 by 7. Next one is, this is your 3 by 7. Okay. Now let us multiply these two matrices. You know how to multiply it. First row by first column. 3 into 2 by 7. 6 by 7. This is 1 into 1 by 7 plus 1 by 7. Right? Again, first row by second column. 3 into minus 1 by 7. Minus 3 by 7 plus 1 into 3 by 7. That is 3 by 7. Okay? Now multiply first row by, multiply second row by first column. Minus 1 into 2 by 7. Minus 2 by 7. Plus 2 into 1 by 7, that is 2 by 7. Again, multiply second row by second column. Corresponding elements should be multiplied. So minus into minus plus. Minus into minus plus 1 by 7 plus next 2 into 3 by 7, that is 6 by 7. Right? So now let us check it. Let us simplify it. So let us simplify it. So is equal to, what is it? 6 by 7. This is 6 by 7 plus 1 by 7. That is 7 by 7, which is equal to 1. Minus 3 by 7 plus 3 by 7 will be cancelled. 0. Minus 2 by 7 plus 2 by 7 will be 0. 1 by 7 plus 6 by 7 will be 1, which is equal to I. So we get A dot A inverse is equal to I. That means this matrix A inverse is the correct answer. So is that understood? So we'll do the next question now. Now we will do next question, that is 10 number 2. If capital A, that is the matrix A is equal to, this is second order matrix. In the first row 4 and 5 are given, and in the second row 5 and 6 are given. You have to show that A square is equal to 10A plus I. You have to show that this LHS is equal to RHS. That is, LHS is equal to A square and RHS is equal to 10A plus I. You have to prove that LHS is equal to RHS, where I is the unit matrix of order 2. Hence, you have to find out the matrix A inverse. Okay. Now, let us prove the first part first. Okay. You prove LHS is equal to RHS. Now, what is LHS there? So, here LHS is equal to A square. You can write it as A dot A, isn't it? So, which is equal to, what is A here? It is 4, 5, 5, 6 dot, what is A here again? It is 4, 5, 5, 6. Is that clear? So which is equal to, now first row by first column. You have to multiply first row by first column. Corresponding elements can be multiplied. 4 4s are 16 plus 5 5s are, this is 25. Again, first row by second column. Corresponding elements can be multiplied. 4 5s are 20 plus 5 6 are 30. Right? Next, second row by first column. 5 4s are 20 plus 6 5s are 30. Now second row by second column. 5 5s are 25 plus 6 6 are 36. Okay? Now you can simplify it further. So which is equal to, what is it now? 16 plus 25, 41. Next, 20 plus 30, that is your 50. Again 20 plus 30, that is also 50. And 25 plus 36, that is 61. That is your 61. So we got this left hand side. Now let us find out right hand side. So now let us find out this right hand side. Okay. So what is right hand side here? It is 10A plus I. It is 10A plus I. Right. Now this is 10. What is I now? What is I? This is the identity matrix of order 2. So here you should write, what is the identity matrix of order 2? It is 1 0 0 1. So it is 1 0 0 1 plus, oh sorry, not 10A, this is the matrix A, right? So it is equal to 10. What is the matrix A here? What is the matrix A out here? It is 4 5 5 6 plus, what is I? You know that I is the identity matrix of order 2. So what is I here? 1 0 0 1. That is 1 0 0 1. Here the leading diagonal are the same element, that is 1 1. Okay. So multiply by 10 out here. It is 10 4s are 40, 10 5s are 50, again 10 5s are 50, 10 6s are 60 plus 1 0 0 1. Is that clear now? So you can add these two matrices, isn't it? So these two matrices can be added because they have got the same order, right? So corresponding elements should be added. That is your 40 plus 1, 41, 50 plus 0, that is 50. Next, 50 plus 0, that is also 50. 60 plus 1, that is 61. Are these left hand side and right hand side equal? Check it. So left hand side here is 41, 50, 50, 61. This right hand side is also 41, 50, 50, 61. That means LHS is equal to RHS, right? So therefore you can write, therefore LHS is equal to RHS proved. Now you have to find out the second part, that is hence you have to find out A inverse, that is you have to find out the inverse of the matrix A. So how can you find out the inverse of the matrix A? You have to use this same relation. Just now we proved it, that is A square is equal to 10A plus I. So we will use this relation to find out the matrix A inverse. Okay. So now write down the relation we just proved, that is A square is equal to 10A plus I, or A square can be written as A dot A is equal to 10A plus I. Now we will use the same method that we applied in the previous problem. Okay, that means you have to multiply both the sides by A inverse and you have to use the properties of matrix. Since you have to get A inverse, you multiply both LHS and RHS by A inverse. Okay, so or this is A inverse dot A. On the right hand side also multiplied by A inverse. So it is, sorry, this is 10 A inverse dot A plus A inverse dot I, right? So next, what is this A inverse dot A? That is I dot A is equal to 10 dot, what is A inverse dot A? That is your I, you know that, plus what is A inverse dot I? That is your A inverse. A inverse into I is A inverse, okay? So what is I dot A again? That is A is equal to 10I plus A inverse. Now you can easily get the value for A inverse, right? So that we can get the matrix A inverse, okay? Or what is A inverse is equal to? What is A inverse is equal to? What is the matrix A inverse is equal to? This is A minus 10I, right? So A inverse is equal to A minus 10I. So or A inverse is equal to, what is A? A is the given matrix, that is 4 5 5 6, right? Then minus 10. Minus 10, what is I here? No, this is the identity matrix. This I is the identity matrix of order 2, that is 1 0 0 1. You should know it, okay? So or A inverse is equal to, this is 4 5 5 6 plus, now multiply all the entries of the identity matrix by minus 10, because here minus 10 is the scalar multiplication of the identity matrix. So it is minus 10 0 0 minus 10, right? So or what is A inverse now? What is the final answer for the matrix A inverse? It is 4 minus 10. minus 6, 5 plus 0, that is 5, 5 plus 0, that is also 5, okay, and 6 minus 10 is minus 4. So this is the final answer. So we got the matrix A inverse, which is equal to, in the first row there are two elements, minus 6 and 5, and in the second row there are two entries, that is 5 and minus 4. So that is the matrix A inverse. Is that clear now? So this is also very, very important question, both 10.1 and 10.2. Okay, so now we'll do the next question. Now we'll do the next question, that is question number 11. If the matrix capital A is equal to 1/3, that is the scalar multiplication of the given matrix, 1/3, and within first bracket 9 elements are given in the form of a matrix. In the first row A22, second row 21B, and the third row 2C1 obeys the law A dot A dash is equal to I. That is A dot transpose of A is equal to identity matrix. Okay, so you have to find out the values of this constant A, B and C. These are the unknown quantities out here, and it is given that it obeys the law, that is A dot A dash is equal to I. What is that dash? A dash is the transpose of A, and what is I? I is the unit or identity matrix of order 3, that is 3 cross 3 matrix. Is that clear? So now let us find out A dot A inverse first. So therefore, first of all, we will get the matrix A dot A inverse. Okay, what is A here? It is 1/3. Matrix A is A22, 21B, and this is 2C1. Right? Next, what is A dash? A dash is the transpose of A. You know the transpose of A. If the matrix A is given, you have to change rows into columns and columns into rows to get the transpose of the matrix A. Right? So into 1/3, that is a scalar multiplication of the matrix. Now let us change rows into columns and columns into rows. So this is the first column, A22. This will become the first row, A22. Okay, now this second column becomes the second row here, 21C, and this third column becomes the third row here, that is 2B1. So I think you have understood it, transpose of the given matrix. So therefore A dash is equal to, now 1/3 into 1/3, that is 1/9. Then you have to multiply these two matrices. You know how to multiply them, isn't it? First row should be multiplied by the first column. A into A square plus 2 2s are 4 plus 2 2s are 4. Right? Next, first row by second column, A into 2, 2A plus 2 into 1, 2 plus 2 into B, 2B. Right? Next one is first row by third column, A2s are 2A plus 2C plus 2. Is that clear? Next row now. Second row by first column, 2 into A, 2A plus 1 into 2, 2 plus 2 into B, 2B. Right? Now second row by second column, 2 2s are 4 plus 1 1s are 1 plus B square. Is that clear now? Next one, this second row multiplied by the third column, 2 2s are 4 plus 1 into C, C plus B 1s are B. Is that clear now? 2 2s are 4 plus C plus B. Is that clear? As the next one is third row by this first column, third row by first column, 2 into A, 2A plus 2 into C, 2C plus 2 ones are 2. Next, this third row should be multiplied by the second column. 2 twos are 4 plus C plus B. This is 2 twos are 4 plus C plus B. Next, this third row should be multiplied by the third column. Corresponding elements should be multiplied. 2 twos are 4 plus C into C, C square plus 1. So this is your matrix. So I think you have understood it. Okay. So let us simplify it now. So let us simplify it. Therefore, A dash is equal to 1 upon 9. So what is the first row here? A square plus 8. This is 2A plus 2B plus 2. Next, 2A plus 2C plus 2. Next, 2A plus 2 plus 2B. Next, this is 4 plus 1, 5 plus B square, right? Then this is 4 plus C plus B, 4 plus C plus B. Next one is 2A plus 2C plus 2. Next, 4 plus C plus B. Next one is 5 plus. Next one is, this is 4 plus 1, 5 plus C square. So this is your A dot A dash. So now what is given there? What was given there? Actually, A dot A dash is equal to I. So given here is A dot A dash is equal to I. So just now we determined the matrix A dot A dash, isn't it? So just now we determined A dot A dash, isn't it? So let us write down this matrix A dot A dash. That is 1 upon 9 A square plus 8, 2A plus 2B plus 2, 2A plus 2C plus 2, right? And next one is 2A plus 2 plus 2B. This is 5 plus B square, and this is 4 plus C plus B. And next, 2A plus 2C plus 2. This is 4 plus C plus B. And the next one is 5 plus C square, right? So which is equal to what is I? Actually, I is 1 0 0 0 1 0 0 0 1. So this is your identity matrix of order 3. That is, the leading diagonal are all, the elements in the leading diagonal are all 1 and all of the elements are 0, right? So now you can multiply by 1 by 9. 1 by 9 is the scalar multiplication of these matrices. Okay, so it is A square plus 8 by 9, 2A plus 2B plus 2 by 9. This is 2A plus 2C plus 2 by 9. And this is also 2A plus 2 plus 2B by 9. Next one, 5 plus B square by 9. So I think I've understood it. Okay. Next one is 4 plus C plus B by 9. Next one is 2A plus 2C plus 2 by 9. Next, 4 plus C plus B by 9. Next, 5 plus C square by 9. Bracket closed, which is equal to, so right hand side remains same, that is identity matrix 1 0 0 0 1 0. This is 0 0 1, right? And so now these are the equality of two matrices. That means these two matrices are equal if they have got the same order and the corresponding elements are also equal. Okay. Now let us equate here to get the values of A, B and C. So in the question you are asked to find out the values of A, B and C. So let us equate this second is equal to second element. That is 2A plus 2B plus 2 divided by 9 is equal to what? 0, right? So if you can equate with 0, it will be easier for you to find out those values of A, B and C, okay? So that means we have equated with 0, right? So or this is 2A plus 2B plus 2 is equal to 9 zeros are 0, or this is 2A plus 2B is equal to minus 2, or here 2 is taken common, A plus B is equal to minus 2. You can cancel this 2 gets cancelled because 2 is not equal to 0. So AB is equal to what is here? It is minus 1. This is equation number 1. Okay. So now again you can equate this 2A plus 2C by 2 divided by 9 is equal to 0, isn't it? So let us equate it. 2A plus 2C plus 2 divided by 9 is equal to 0. Okay. So let us cross multiply it. 2A plus 2C plus 2 is equal to 0, or 2A plus 2C is equal to minus 2. So here also 2 is taken common. So within bracket A plus C is equal to minus 2. 2 gets cancels. So what do we get? Therefore A plus C is equal to minus 1. Suppose this is equation number 2. Now which one will you equate? So we have already equated 2A plus 2 plus 2B by 9 is equal to 0. Okay, but we haven't equated 4 plus C plus B by 9 is equal to 0. So let us write it. Again you can equate these two elements 4 plus C plus B whole divided by 9 is equal to what? 0, or 4 plus C plus B is equal to 9 zeros are 0. Is that clear? Next, what is the value for B plus C? B plus C is equal to minus 4. Let us mark it number 3. Now you have to solve number 1, number 2 and number 3 to get the values of A, B and C. So how will you solve it? Number 1, number 2 and number 3. Let us add all this equation 1, 2 and 3. Okay. So adding 1, 2 and 3. So let us write all these equations. A plus B is equal to minus 1. Then comes A plus C is equal to, that is also minus 1. And B plus C is equal to what? It is minus 4. Let us add them. A plus A, 2A plus 2B plus 2C is equal to, that is your minus 6, isn't it? Minus 1, minus 1, minus 4. All are the same sign, so you can add them. That is your minus 6, right? So what is common on the left hand side? What is common on the left hand side? 2 is common. Let us take it outside. So 2 is taken common. A plus B plus C is equal to minus 6, right? So what is the value for A plus B plus C is equal to? A plus B plus C is equal to minus 3. Let us mark it number 4, right? Now you have to get the individual values of A, B and C. So how do you get it? 4 minus 1, that is you can write 4 minus 1, that is A plus B plus C is equal to minus 3. Then write number 1, A plus B is equal to minus 1. So you can subtract them, minus minus, this is plus. So what do we get? A gets cancels, B gets cancelled. So C is equal to, what is it? What is C is equal to? Minus 2. Okay. So we get C is equal to what? It is minus 2. Is that clear? Next, again, 4 minus 2. Let's do 4 minus 2. So what do we get? 4 minus 2. Now write A plus B plus C is equal to minus 3. And what is minus 2? This was 4 minus 1. Okay. So 4 minus 2 is, that is A plus C. A plus C is equal to minus 1. Right? So minus minus, this is plus. Is that clear now? So here you can cancel this A and C gets cancelled. So what is the value of B? B is equal to what? It is minus 2. C is equal to minus 2, B is also minus 2. Now you can do 4 minus 3. You can do 4 minus 3. So write down number 4. What is number 4? A plus B plus C is equal to minus 3. Okay. Then minus 3. B plus C is equal to, what is it? Minus 4. Right? So minus minus, B gets cancelled, C gets cancelled. This is plus. That is, what is the value for A? A is equal to, what is it? A is equal to 1. Is that clear? So we got this answer. That is, A is equal to 1, B is equal to minus 2, and C is equal to what? C is also minus 2. So let us write down the answer now. That is, A is equal to 1. What is B is equal to? This is A is equal to 1, B is equal to minus 2. And what is the value for C? C is equal to minus 2. So this is the answer. This is the final answer. Okay. So this question is very, very important. You can revise it at home. Okay. We'll do the next question now. Now, we will do question number 12. If capital A is equal to, in the first row, 1 minus 2, 2 is given. In the second row, 0, 1, minus 1, and in the third row, 0, 0, 1 are given. Okay? And what is B matrix? It is also 3 cross 3 matrix. In the first row, 1, 2, 0 are given. Second row, 2, 3, minus 1, and in the third row, 0, minus 1, minus 2. You have to show that A dash B within bracket and outside A dash B, it is given as A is a diagonal matrix. What is a diagonal matrix? In the diagonal matrix, the leading diagonal should be non-zero and all of the elements should be 0. Like you should get the answer like this, okay? Like 2, 3, 4. You may not get 2, 3, 4 as in the leading diagonal, okay? And all of the elements 0. The matrix should be like this, okay? The leading diagonal should be non-zero and all other elements should be 0, right? So this is known as diagonal matrix. Now first of all, let us find out A dash B. So let us find out A dash B, okay? So therefore, A dash B. Now you know what is A dash? A dash is the transpose of the matrix A. How can you get the transpose of the matrix A? So in the given matrix A, you have to change rows into columns and columns into rows to get A dash. So now what is A dash here? 1, 0, 0 is the first column. This will be the first row. 1, 0, 0. Second row, minus 2, 1, 0. Minus 2, 1, 0. What is the third row now? It is 2, minus 1, 1. That is your A dash. Now let us write down B. What is B out here? It is 1, 2, 0, 2, 3, minus 1, 0, minus 1, minus 2. Now you can multiply these two matrices. Okay? So let us multiply these two matrices now is equal to, now first row by first column. 1 1s are 1, plus 0 2s are 0, plus 0 0s are 0. So this is the first element of the first row. Now first row is multiplied by the second column. 1 2s are 2 plus 0 3s are 0. 0 into minus 1. You can write plus 0. Okay. Again, first row by third column. 1 0s are 0. Plus 0 into minus 1 0. Plus 0 into minus 2. That is also 0. Is that clear? Next, this second row should be multiplied by the first column. Corresponding elements should be multiplied. Minus 2 into 1, that is minus 2 plus 1 2s are 2 plus 0, right? Minus 2 into 1, minus 2 plus 2, 0. Again second row by second column, minus 2 into 2, minus 4 plus 3 1s are 3 plus this is 0. Again second row by third column, minus 2 into 0, 0. 1 into minus 1, minus 1, plus 0 into minus 2, minus 0. So I think you have understood it. Okay. Next, you will write third row by first column. 2 into 1, 2. This is minus 2 plus 1 0 is 0. Next, third row by second column. 2 2 is 4, minus 3, minus 3. This is minus 1. Okay. Next, third row by third column. 2 0 is 0, minus 1 into minus 1, plus 1, 1 into minus 2, minus 2. So this is the multiplication of these two matrices. Okay. Now we have to simplify it. Let us simplify each and every element in this matrix. Okay. So which is equal to, what is it now? 1 plus 0 plus 0, that is 1. 2 plus 0 plus 0, 2. 0 plus 0 plus 0, that is 0. Minus 2 plus 2 plus 0, that is 0. Minus 4 plus 3, minus 1. 0 minus 1 minus 0, that is 0 minus 1. Right? 2 minus 2, 0. 4 minus 3 minus 1, 0. Then minus 1. Is that clear? So this is the matrix A dash B. Okay. Now what is to be found out? Now we have to determine A dash B into A. So now let us find out A dash B into A. So which is equal to, next, what is A dash B? We just now got this matrix A dash B, right? So it is 1 2 0 0 minus 1 minus 1 0 0 minus 1. Is that clear? Next, write down the matrix A. Let us write down the matrix A now. What is it? 1 minus 2, 2, right? Then 0 1 minus 1, 0 1 minus 1. Next 0 0 1. Next is 0 0 1. So this is the second matrix, that is A matrix. Okay. Now let us multiply these two matrices to prove that this A dash B into A is the diagonal matrix. Okay. So is equal to, now let us multiply these two matrices. First row by first column, 1 1 is 1 plus 2 zeros are 0 plus 0 zeros are 0. Right? Again this first row by second column. What is this first row by second column? 1 into minus 2. Minus 2 plus 2 ones are 2 plus 0. Next, first row by this. First row by this. First row by third column. 1 2s are 2. Okay. 2 into minus 1. Minus 2 plus 0 ones are plus 0. Right. This is the first row. Now, second row by first column. 0 ones are 0, minus 1 into 0 plus 0, again minus 1 into 0 plus 0, right? Next, second row by second column, what is it? 0 into minus 2, 0, minus 1 into 1, minus 1, minus 1 into 0, that is plus 0, right? Next, second row by third column, 0 2s are 0, 0 2s are 0, minus 1 into minus 1, plus 1, minus 1 into 1, that is your minus 1, right? Again, third row by first column, what do we get? 0 1s are 0 plus 0 zeros are 0 plus minus 1 into 0, that is always 0, right? Next, this third row by second column, 0 into minus 2, 0, 0 into 1, plus 0, plus minus 1 into 0, not that one. Third row by third column. Third row by second column. That's right. 0 into minus 2, 0. 0 into 1, 0. Minus 1 into 0, that is plus 0. Right? Next, third row by third column. Third row by third column. Corresponding elements should be multiplied. 0 2s are 0. 0 into minus 1 plus 0. Then minus 1 into 1 is minus 1, right? This Minus 1 into 1 is minus 1. Is that clear? So which is equal to, how much is it? 1 plus 0 plus 0, 1. This is 0. That is also 0. This is 0. This is minus 1. This is 0. This is 0. 0. That is minus 1. So here, the leading, this is known as the leading diagonal. That is, this is the first column. This is the first column. There are two elements 0 and this first element is non-zero. And this in the second column, the second element is non-zero. And in the third column, the third element is non-zero. So this is known as the leading diagonal. If this leading diagonal are all non-zeros, but all of the elements are 0, this is known as diagonal matrix. Hence, the given matrix, that is hence A dash B into A is a diagonal matrix. Because here the leading diagonal are all non-zeros, but all of the elements are zeros, right? So hence, what will you write? Hence A dash B within bracket into A is a diagonal matrix. Is a diagonal matrix. So is that clear to all of you? So this is the answer. So we'll do the next question now. Now we'll do the next question, that is question number 13. It is very, very important question. Express the matrix A is equal to, the third order matrix is given out here and all the elements are kept within third bracket. So in case of matrix, all the elements will be arranged within third bracket or first bracket, but in case of determinant, those two vertical lines are given and within that two vertical lines, the elements are arranged. Okay? So this is the matrix A is equal to, third order matrix is given. In the first row 4 2 minus 1, in the second row 3 5 7, and in the third row 1 minus 2 1 are given. You have to express this matrix as the sum of a symmetric matrix and a skew symmetric matrix. So in the previous classes, in the previous online classes, I told you about these two matrices, that is what is a symmetric matrix and what is a skew symmetric matrix. Let us do the revision. Okay? So what do you mean by symmetric matrix? What do you mean by symmetric matrix? A matrix A is said to be a symmetric matrix if A is equal to A transpose. Right? Suppose a matrix A is given, you find out the transpose of the matrix A. If you can prove that A is equal to A transpose, then that matrix A is a symmetric matrix. Okay? So like example is what? Example is, suppose matrix A is given as A, H, Z, H, B, F and Z, F, C. Okay? This is the leading diagonal ABC. If there is H, this will be H, G, G, F, F. So if you transpose it, what do you get? This first column becomes the first row, A, H, Z. This second column becomes the second row, H, B, F. And this third column becomes the third row, that is Z, F, C. So again, compare these two, A, H, Z, A, H, Z, H, B, F, H, B, F, G, F, C, G, F, C. But we have changed rows into columns and columns into rows, isn't it? But we have got the same matrix here, A is equal to A transpose. So this type of matrix is known as what? Symmetric matrix. Okay, this is your symmetric matrix. This is your symmetric matrix. Okay, now what do you mean by skew symmetric matrix? So what is a skew symmetric matrix? So now what is meant by skew symmetric matrix? So suppose a matrix A is given and find out its transpose. But if you find out A transpose is equal to minus A, okay, a matrix A is given, you find out the transpose of the matrix A, If you can prove that A transpose is equal to minus A, then that matrix A is said to be a skew symmetric matrix. Is it clear now? So now I'll give you the example. A is equal to, the leading diagonal should be 0 always, right? If it is H, it should be minus H, opposite sign. If it is minus Z, it should be opposite sign Z out here. And if it is F, it should be minus F, right? So this is a skew symmetric matrix. So how is it a skew symmetric matrix now? Now we have to prove it, okay? That is A transpose is equal to, let us make A transpose here, okay? That is rows into columns and columns into rows. Now this is the first column, becomes the first row, 0 minus HG. This second column becomes the second row here, H0 minus F. And this third column becomes the third row, that is minus ZF0. Is that clear to all of you? So now what will you do in the next step? So in the next step, you take minus common throughout the term. From all the terms, you take minus common. Okay? So A transpose, in case of matrix, you have to take common from all the elements. But in case of determinant, you cannot do so. You cannot take common from all the elements in case of determinant. In case of determinant, either from the first row or from the second row or from the third row or from the first column or from the second column or from the third column, you should get common. But in case of matrix, you have to take common from all these elements. Okay? So here minus is taken common. So what do we get? 0 H minus Z minus H 0 F, and this is Z minus F0. Okay? That means A transpose is equal to minus, again same matrix A is there, isn't it? Compare these two. 0H minus Z minus H0F, Z minus F0, that is A. So if you can prove that A transpose is equal to minus A, then that matrix A is a skew symmetric matrix. So I think you have understood it. Okay? So now, in this case, you have to express A, given matrix A, as the sum of a symmetric matrix and a skew symmetric matrix. So in that online class also, in the previous online class, I told you how to convert a given matrix as the sum of symmetric matrix and a skew symmetric matrix. There was a formula, right? The formula was actually, how do you write it? Suppose the matrix A is given. This matrix should be converted as the sum of a symmetric matrix and a skew symmetric matrix. Okay? So you just write A plus A transpose first. Okay? But there is only A here. So let us write here A minus A transpose. If we add these two matrices, you will get 2A. A transpose minus A transpose will cancel, that's right. But if you add these two matrices, you are getting 2A, isn't it? But you should get only A. So multiply it by half and multiply it by plus half. So if you simplify it, what do we get? Half A transpose minus half A transpose will be cancelled, and half A plus half A will be 2A by 2, which is equal to A matrix. So this will be your symmetric matrix. This will be your symmetric matrix, and this will be your what? This is your skew symmetric matrix. So is that clear to all of you? So this is the theoretical part of the symmetric matrix and skew symmetric matrix. Now let's do the problem now. Okay? So now we'll do the problem. That means you have to express the given matrix. You have to express the given matrix A as the sum of a symmetric matrix and a skew symmetric matrix. Okay? So let us write down the given matrix. So here, given matrix A is equal to, what is it? It is 4, 2, minus 1. It is 3, 5, 7, 1, minus 2, 1. This is the given matrix A. Right? Let us find out its transpose. Transpose of A. A transpose is equal to, what is it? And now this first column becomes the first row. 4, 3, 1. second column becomes the second row, 2, 5, minus 2, and this third column becomes the third row, that is minus 1 and 7, and this is 1. Is that clear to all of you? So let us find out the sum of these two matrices, that is A plus A transpose. So A plus A transpose is equal to, what is A out here? What is A now? So here A is, what is A? This is 4, 2, minus 1, then 3, 5, 7, 3, 5, 7, and then 1 minus 2, 1. Okay? So plus, what is A transpose? This one is the A transpose, that is 4, 3, 1, 2, 5, minus 2, right? Then minus 1, 7, 1. Minus 1, 7, 1. So these are the two matrices, you have to add them. You can add them because they are of same order and the corresponding elements should be added. So 4 plus 4, 8, 2 plus 3, 5, minus 1 plus 1, that is 0. Next, 3 plus 2, 5, 5 plus 5, 10, and 7 minus 2 is your 5, right? Next, 1 minus 1, that is 0, minus 2 plus 7, that is your 5, so 1 plus 1 is 2. So this is a symmetry matrix because 8, 10 and 2 are the leading diagonal. If it is 5, this is also 5. This is 0, this is also 0. If this is 5, this is also 5. If you change it into, if you change rows into columns and columns into rows, you will get the same matrix, that is A plus A transpose. So this is a symmetric matrix, okay? So next, you have to find out A minus A transpose. Again you have to get what? A minus A transpose is equal to, what is A out here? Let us write down A. 4, 2, minus 1, 3, 5, 7, 1, minus 2, 1. Then minus, what is A transpose out here? It is 4, 3, 1, 2, 5, minus 2, and minus 1, 7, 1. So you can multiply this second matrix by the scalar quantity, that is minus 1. So it is 4, 2, minus 1, 3, 5, 7, 1, minus 2, 1. Let us write it as plus sign. So now multiply all these elements of the second matrix by the scalar quantity, that is minus 1. So minus 1 into 4 is minus 4, minus 3, minus 1, right? It is minus 2, minus 5, plus 2. It is plus 1, minus 7, minus 1. So this is the matrix. You can add them now. So how much is it? 4 minus 4, 0. 2 minus 3, minus 1, minus 1. Minus 1, that is minus 2. 3 minus 2, that is 1. 5 minus 5, 0. And 7 plus 2 is 9. Again, 1 plus 1 is, this is 2 minus 7, minus 9, 1 minus 1 is 0. So how can you say that this is a skew symmetric matrix? The leading diagonal are all zeros. If it is minus 1, it is plus 1, minus 2, plus 2, this is 9, minus 9. So this is a skew symmetric matrix. So now you have to express this given matrix A as the sum of the symmetric matrix and the skew symmetric matrix. Okay? Now what will you do now? Now what will you do? That is A is equal to, this was half A plus A transpose, plus half A minus A transpose. This was the formula, right? So this was the formula for what? This was the formula for half within bracket A plus A transpose, and A is equal to half into A plus A transpose plus half into A minus A transpose. This first matrix denotes the symmetric matrix, and this second matrix denotes the skew symmetric matrix. Okay? So therefore, A is equal to half. Just now we found out A plus A transpose, isn't it? But I have rubbed it there. So this is your A minus A transpose, that is correct, okay? So let us write it as A minus A transpose, okay? So half into A plus A transpose, I forgot it. Okay. So again I have to repeat that video, but I have to pause it. But instead of that, again I will find out A plus A transpose. Okay. So this is your A plus A transpose, isn't it? So this is your A minus A transpose. You can pause the video and see it. Okay. And you can see A plus A transpose. What was that? Right. So is equal to, and now it is 4 plus 4. It was 8. 2 plus 3, it was 5, minus 1 plus 1, it was 0, 3 plus 2 is 5, 5 plus 5 is 10, 7 minus 2 is 9, this is 0, this is, 7 minus 2 is, how much is it? 5, isn't it? 7 minus 2 is 5, this minus 2 plus 7 is 5, and 1 plus 1 is 2 out here. So this was actually A plus A transpose, okay? So half you can write here. What is A plus A transpose? It was 8, 5, 0, right? Next 5, 10, 5, 10. This is also 5, right? 0, 0, then comes 5, then comes 2. Plus half. What was A minus A transpose? It is this one. Right? 0 minus 1 minus 2, 0 minus 1 minus 2. Next, 109, right? It is 109, okay? And this is 2 minus 9, 0. 2 minus 9, 0. So I think you have understood it. So now let us write down the answer now. So we have expressed A as the sum of a symmetric matrix and a skew symmetric matrix. You have to multiply all these elements of the matrix by, that is, scalar quantity half. Okay, so half into 8, that is 4. It is 5 by 2, 0. Half into 0 is 0. Half into 5, 5 by 2. Half into 10, that is your 5. Half into 5, that is your 5 by 2. Again, half into 0, that is 0. Half into 5 is 5 by 2, and next one is half into 2 is, that is 1. So this is your symmetric matrix, okay? Plus half into that skew symmetric matrix, what is it? Half into 0 is 0, 0 minus half, half into minus 2 minus 1, right? And then next one is half into 1. That is half into 0, 0, half into 9, that is your 9 by 2. So half into 2, that is 1, half into minus 9 by 2, and the last one is half into 0, half into what? Half into 0 is always 0. So this is the answer. That means this first matrix is the symmetric matrix plus this second matrix is the skew symmetric matrix. So we have converted the given matrix as the sum of a symmetric matrix and a skew symmetric matrix, and this first matrix is the symmetric matrix and the second matrix is the skew symmetric matrix. Is that clear? So this question is very, very important. Okay, so we'll do the next question now. Now we are doing question from HS 2020 this year. This question had come this year, HS 2020, that is 2B number 1. If capital A is equal to second order matrix is given, but the entries are trigonometric functions here. Cos theta, sin theta, minus sin theta, cos theta are given. You have to show that a to the power n is equal to, within bracket, cos n theta, sin n theta in the first row, and minus sin n theta, cos n theta are in the second row, where n is equal to a positive integer. Okay, so if a is equal to cos theta, sin theta, minus sin theta, cos theta, you have to prove that a to the power n is this one. So in this case, we will use mathematical induction to prove this relation, a to the power n is equal to that one. Okay, so in class 11 you did mathematical induction, isn't it? So let us use mathematical induction to prove it. You know mathematical induction, isn't it? So let us prove it using mathematical induction. Okay. So let us use the statement. Let us write this which is to be proved in terms of mathematical statement. So let us write, let P of n denote the mathematical statement, P of n such that, this is your such that, isn't it? In mathematical notation, this colon, in English this is colon, but in mathematical notation it is known as such that. Okay, Pn such that a to the power n is equal to this is cos n theta, sin n theta, then minus sin n theta, then cos n theta. Okay, so now first of all we will show that P of 1 is always true. P of 1 is always true. If you put n is equal to 1, so what do we get? Putting n is equal to 1. What do we get? That is P of 1 such that a to the power 1 is always a is equal to cos theta sin theta minus sin theta cos theta. So in this case we are putting n is equal to 1. Okay, so we got this relation, but this is the given relation. A question might give us a given relation, and that means it is proved. That is P1 is true. So that is, we can write down here that therefore P of 1 is true. So we have proved that P of 1 is true. Now what is mathematical induction actually? If P of 1 is true, you should prove that P of 2 is true. If P of 2 is true, then P of 3 is true. If P of 3 is true, then P of 4 is true. Let us generalize it. Okay? So let this P of n be true. Let this P of n be true whenever n is equal to m. Let P of n be true whenever n is equal to m. Okay? So we are proving that if P1 is true, then P2 is true. If P2 is true, P3 is true. If P3 is true, P4 is true, and so on. Okay? So now we will generalize it. Let us assume that let P of n be true whenever n is equal to m. Let P of n be true. Let this statement P of n be true whenever n is equal to m. Whenever n is equal to m. Is that clear? Now in this mathematical statement, you put n is equal to m. So P of n such that a to the power m is equal to, within bracket or within first bracket or within matrix notation, you can write cos m theta, right? Then sin m theta, and then this is sin n theta, and this is cos n theta. That means we have written here P of m is also true. Now you will prove that P of n plus 1 is true. Okay? So here we have written here P of n is true whenever n is equal to m. That is, let Pn be true whenever n is equal to m. That means this P of n is true whenever n is equal to m. Now we have to show that P of n plus 1 is also true. अब हामी के प्रुभ गर्छौं अरे so यहाँ मैले रफ लेखेँ यो P of n plus 1 is true भनेर हामीले प्रुभ गर्छौं. So if P of n is true, you have to prove that P of n plus 1 is true. You have to show it. You have to prove it. Okay? So if you prove it, what can we understand from it? If P1 is true, P2 is automatically true. If P2 is true, P3 is true. If P3 is true, P4 is true. If P4 is true, P5 is true. That is your generalized. That means it is true for all natural values of n. Hence it is true for all natural values of n. So this is known as mathematical induction process. So hence, by the principle of mathematical induction, we can write down that this is always true. That is, a to the power n is equal to cos n theta sin n theta minus sin n theta cos n theta. That this process you have done it in class 11, right? So now let us prove that p of n plus 1 is also true whenever this Pn is true. So we have written here p of n is true. Now we have to prove that p of n plus 1 should be true. That means you have to prove p of n plus 1 such that a to the power m plus 1 is equal to, you should prove cos of m plus 1 theta, then sine of n plus 1 theta, then minus sine of n plus 1 theta, then cos of this is your n plus 1 theta. But you have to prove it. Don't leave it like that. Okay? Don't leave it like this only. You have to prove this one. That is, a to the power n plus 1 is equal to this matrix. Okay? So let us prove it now. So here n is a positive integer, means all the values of n are natural numbers here. That is, n is equal to 1, 2, 3, 4, etc. Okay? You have to prove that in this case, this is true for all natural values of n. That is, n is equal to 1, 2, 3, 4, etc. Okay? So we have already proved that p of 1 is true. If you can prove that p of n plus 1 is true whenever pm is true, that is, p1 will be true, then automatically p2 is true. If P2 is true, P3 is true. If P3 is true, P4 is true, and so on. That is, it is true for all natural values of n. Okay? Now let us prove this P of m plus 1 is true wherever P of m is true. So what is left hand side out here? So what is left hand side? A to the power m plus 1, which is equal to, now you can simplify it further, a to the power m into a. You can break it. Isn't it? You can split the term here, a to the power m into a. What is a to the power m here? This is a to the power m. What is a to the power m? It is cos n theta, then sin n theta, then minus sin what? n theta, then cos m theta. Right? This is from a to the power m. Next, what is a? A is the given matrix. Write down the given matrix out here. How much is it? It is cos theta sin theta, then minus sin theta cos theta. Now we will prove this right hand side. Okay? Let us prove it. Now this is the, you should get this relation, right? So now this is the multiplication of the two matrices, isn't it? So is equal to, you can multiply these two matrices, first row by first column, cos n theta into cos theta, cos n theta cos theta, then this second element should be multiplied. This is minus sin n theta sin theta, right? This is the first element of the first row. Next, first row should be multiplied by the second column, cos n theta into sin theta, cos n theta sin theta, plus what? Sin n theta cos theta. Sin n theta cos theta. Is that clear? So we have multiplied first row by first column, and we have written out here, this is the first element, and this first row is multiplied by second column, that is, corresponding elements are multiplied, and we have written here as a second element of the first row. Now second row by first column, what do we get? This is your minus sin n theta cos theta minus cos n theta sin theta. These two elements are multiplied, and we have written here, and again these two elements are multiplied, and we have written out here. That is the first element of the second row. Next, this second row should be multiplied by second column. What is it? How much is it? Minus sin n theta minus sin n theta sin theta plus cos n theta cos theta. So here bracket is closed. Is that clear to all of you? Now let us simplify it. Now we can simplify it further, right? So is equal to, now what is the formula here? Cos A cos B minus sin A sin B. What is cos A cos B minus sin A sin B? Cos of A plus B m theta plus theta, and this one cos A cos B sin A cos B plus cos A sin B, that is sin of A plus B sin of m theta plus theta, right? And here minus is taken common, so within bracket we have plus sign here. So what is the formula? Sin of A plus B m theta plus theta, and here cos A cos B minus sin A sin B. What is the formula? Cos of A plus B, that is m theta plus theta. So I think you have understood it. This is the formula from compound angle in trigonometry. Okay, so now next, simplify it. Cos of what is common here? Theta, so it is n plus 1 theta, and here sin of within bracket m plus 1 theta, and here minus sin, here theta is common, m plus 1 theta, and then cos of, this is also theta is taken common, so cos of m plus 1 into theta. So we have proved it, isn't it? That is a to the power n plus 1 is equal to this matrix. So we have proved that P of n plus 1 is true whenever P of n is true. So write down. Therefore, P of n plus 1 is true. Class 11, lesson 11, we have written like this in class 11. Therefore, P of n plus 1 is true whenever P of n is true. Whenever P of n is true. Now what will you write? So in the first, in the previous steps, we proved that P of 1 is true, isn't it? So let us write here, since we have proved that P of 1 is true, isn't it? Since P of 1 is true and P of n plus 1 is true whenever P of n is true. Just now we proved it, isn't it? Just now we proved that P of n plus 1 is true whenever P of n is true. Therefore, P of n is true for all positive integral values of, therefore P of n is true for all positive integral values of n. For all positive integral values of n. Right? So you can write down that, hence by principle of mathematical induction, hence by the principle of mathematical induction, hence by the principle of mathematical induction, comma, we have, so write down that question, what was to be proved? So hence by the principle of mathematical induction, comma, we have, write down the statement, what is to be proved? That is, an is equal to, what was that? Cos n theta sin n theta, then minus sin n theta, then what is there? Cos n theta. So it is done, proved. So proved, that is LHS is equal to RHS. Okay. So now I'll give you the homework, right? So now these are your homework, and these two questions are from the book, and this is from the HS question paper. You can do them. Okay. So 10 number 3 is, so that the matrix A is equal to, second order matrix is given 2 minus 3, 3 and 4 satisfies the equation A square minus 6A plus 17 is equal to norm matrix, that is O. You prove LHS is equal to norm matrix first. Okay. This is, it is given A square, this is square. Okay. So this is your A square minus 6A plus 17I. You have to write 17I. and then prove that is equal to normal matrix, and hence you have to find out A inverse. Using the properties of matrix, you can find A inverse. Okay. And similar question is for 18. Now this is the third order matrix, so you know how to satisfy, how to prove that this matrix A is equal to this matrix satisfies the equation A square minus 4A minus 5i3 is equal to normal matrix, and hence you have to find out A inverse. Okay. And HS 2019 1b, A is equal to 8 0 4 minus 2, that is the second order matrix, and B is equal to it is also second order matrix, 2 minus 2 minus 5 and 1. Find the matrix X where 2A plus 3x is equal to 5b. You know how to do it, isn't it? Next one is if A is equal to, you know, this is the complex number I. If A is equal to I minus I, and B is equal to 1 minus 1 minus 1, 1. Then so that A to the power 8 is equal to 128b. You can easily find out 128b, isn't it? How can you find out A8? You first find out A square, A dot A. Then again find out A to the power 4, A square dot A square. Again find out A to the power 8, that is A to the power 4 into A to the power 4. That will give you A to the power 8. Okay? And prove that A to the power 8 is equal to 128b. Is that clear? Next one is from HS 2018. To be number 1, you can do this question. Express matrix A is equal to 3 2 3 first row, 4 5 3 second row, 2 4 5 third row as the sum of a symmetric matrix and its two symmetric matrix. In the previous problems, I have shown you this type of problem, isn't it? So you can do it at home. You have to express the matrix, given matrix A as the sum of a symmetric matrix and its two symmetric matrix. You know the method how to express matrix A as the sum of the symmetric matrix and the skew symmetric matrix. So is that clear? So this much is for today. So in the next class we will do more problems, that is how to solve a given equation, how to solve given equations with the help of matrix inversion method. So we'll discuss about the topic cofactors, minors, adjoint and inverse of a matrix. So first of all we will discuss about that 4 topics, that is cofactor, minor, adjoint and how to get the inverse of a given matrix. Okay, then we'll discuss about how to solve a given system of equations with the help of inverse matrix method. Is that clear? So we will do it in the next class.